Alright, I'm going to start with the 2-5 today for compare proportional relationships and go through these answers with you. So the first one is two trains traveling at a constant rate. Find the rate of each train. Which train is traveling at a faster rate? So for train A, they're going in 2 hours, they went 50 miles, 3 hours, 75, 400, 5, 125, and so on. Okay, so we're going to be dividing our distance by our time here to find our constant rate of change or our unit rate. So I'm going to take 50 and divide it by 2, 75 divided by 3, 100 divided by 4, and so on. All of these will give us the same answer since it's a train traveling at a constant rate. When I divide those out, I get my rate for train A as 25 miles per hour. Okay, and then we go down to train B. Train B is shown on this graph. So we're looking for at 1 hour, how many miles did train B travel? So I'm going to go to my graph. Here's 1 hour. I look up and it is at 20 miles for 1 hour. So for my constant rate of change for train B, I'm at 20 miles per hour. So really I'm comparing a 25 miles an hour to 20 miles an hour, and since I know 25 miles an hour is faster, since it's going more distance in the same amount of time, I will say that train A has the faster rate. Okay, moving on to number 2. A 16-ounce bottle of water from store A costs $1.28. The cost in dollars Y of a bottle of water from store B is represented by the equation Y equals 0.07x, where x is the number of ounces. What is the cost per ounce of water at each store? So we're looking for the cost per ounce. So I'm going to be taking my numbers here and making them into unit rates. For my store A, it was $1.28 for 16 ounces. So if I want to find for 1 ounce, I'm essentially going to divide 128 by 16, and that will tell me the price for 1 ounce of soda. When I divide that out, I get $0.08, which is 8 cents. Okay, so store A costs 8 cents. For store B, they represent it as Y equals 0.07x. X represents the number of ounces. Again, I'm trying to find 1 ounce of water, so I am going to multiply 0.07 by 1, which gives me 7 cents. Okay, so I'm looking for which store has the cheapest cost, and that will be store B, since 8 cents is more than 7 cents. Alright, 2-6, we are connecting proportional relationships and slope. So for this one, I'm going to look for the slope of this line. To find the slope of this line, a couple ways you can do it. One is to just simply look at the rise over run from 2 points on your graph. So I'm going to look at 0, 0. It also goes through 6, 5. So for those 2 points, I'm going to be looking at what was my rise and what was my run. I went up 5 and I went over 6. Slope is written as the rise over run. So my rise was 5, my run was 6, so my slope is 5/6. If you wanted to use 2 points to find the slope and use the formula for slope is y2 minus y1 over x2 minus x1. And if I'm using the points 0, 0 and 6, 5. I could use those points and plug in. So I would have, I'm going to label my first point here as my x1 and my y1, and my second point here as my x2 and my y2. And I would plug in these values for this equation. So my y2 is 5, my y1 is 0, so I'd be doing 5 minus 0 over x2, which is 6, minus x1, which is 0. 5 minus 0 gives me 5. 6 minus 0 gives me 6. Again, my slope is 5/6. In this situation, that's the second part of the question, this means that for every 5 cans of yellow paint, I need 6 cans of blue paint. Or for every 5, whatever the measurement is of yellow paint, I need 6 of blue paint for that. All right, 2-7, we're talking about a mixture of nuts containing 1 cup of walnuts for every 3 cups of peanuts. So looking at this graph, I know that they're using my peanuts as my y, or my x value, and my walnuts as my y. Since we talked about before, your slope is your y's over your x's, we're talking about our walnuts divided by our peanuts, and that's going to give us our slope. So for this problem, they say a mixture of nuts contains 1 cup of walnuts. So I'm going to put the 1 on top where the walnuts is, and then for every 3 cups of peanuts. So I would put 3 on the bottom. This is my slope now, 1/3. To write it as an equation, I'm going to take that and I'm going to plug it in for my variable m in my equation y equals mx. This is the proportional relationship equation. So your m stands for your slope. So once you find your slope, you're going to go ahead and plug that in for m. So my equation would be y equals 1/3 x. And then to graph this, since it's a proportional relationship, it's going through the point 0, 0. So I'm going to start at 0, 0. 1/3 tells me that I have a rise of 1 and a run of 3, because rise over run for slope. So I'm going to start at 0, 0. I'm going to rise 1 and run 3. 1, 2, 3. Here's my final point. And I would draw a straight line connecting those 2 points. For 2-8, they have an equation and they want us to find the y-intercept. For y-intercept, it's just where does this line meet or cross the y-axis. Your y-axis is this vertical axis. So I'm going to look at where does this line, if I were to connect it down, where is it crossing my y-axis? It's crossing right here at 5. Okay, so my y-intercept is 5, or I can represent it as a coordinate, which is 0, 5, because that's the point that this is at, 0, 5. And then in this case, it wants to know what does the y-intercept represent. Well, it tells us that we're getting a car wash and then using the vacuum for however many minutes. So if we don't use the vacuum, meaning we used 0 minutes of the vacuum, why are we still being charged $5? Well, this $5 is actually coming from the price of getting the car wash. We may not be using the vacuum, but we're still using the car wash. So that is what the 5 represents in this equation. So $5 for the car wash. All right, and then the last section for the test tomorrow is 2-9. So they wanted us to graph these lines. So whenever you're graphing, it's going to be in the slope-intercept form, which is y equals mx plus b. For this problem, my b, and for all problems, the b represents your y-intercept, and the m represents your slope, as we talked about earlier. Okay. In this equation here, I have y equals 1/2 x minus 1. My minus 1 is going to represent my y-intercept. So I'm going to start my graph at 0, -1. From there, I'm going to use my slope to draw my line. So my slope is right in front of my x. 1/2. 1 represents my rise, 2 represents my run. So I'm going to start at my y-intercept. I'm going to rise 1 and run 2. 1, 2. Here's my second point, and I would connect those dots. Okay, and then for this number 2, they want us to find the equation of the line, so they already drew a graph. I'm going to look for my y-intercept first, so I've got to identify 2 things. What's my y-intercept? What's my slope? Once I have those 2 things, I can solve. My y-intercept I'm going to represent as the b in my equation. My slope I'm going to represent as the m. In this line, it crosses the y-axis at +3. So my y-intercept is 3. From this point, I'm going to look for another point on my graph that the line directly crosses, and I look right here, and I can see that it crosses through this point on the graph. So I'm asking myself, how am I going from left to right from my y-intercept to this point here? Again, we're looking for our rise over run. In this case, since it's going down, we're actually going to have a negative slope. I'm going down 1 and over 1. So my rise is a -1. My run is a +1. I went down 1 and over 1, so -1 over 1. And I'm going to simplify that to -1. Once you have your terms, you're going to plug them into your slope-intercept form equation, which is y equals mx plus b. So I would have y equals my m, which is my slope, -1, x plus my b, which is 3. Y equals -1 plus 3. Okay, and that's all the problems that we have. I have the other videos posted if you would like to watch those, but hopefully this helps you, and good luck with studying.